lecture. So this is what we are going to study: intermediate representation. Okay, this is the part intermediate representation. We called it as IR. Okay, so what we have done so far is that we have done the translation part also. Now we are going for intermediate code representation. Instead of intermediate code means IR, intermediate representation, we are going to work with. So in case of intermediate representation, the most famous concept that comes here in case of intermediate representation is three addressing codes. Okay, so we are going to work with three addressing codes. Hmm. So what are the important points? Like, say for example, if we have an expression, say if we have an expression, say like this, take a case. If we have an expression, say a plus b star c multiplied by d plus a plus b plus c. If this we have an expression and this assignment is, say for example, the result is assigned to a. So if you look at this expression, this is a lengthy expression, right? This is a big expression. Okay, which includes series of operations also, right? And like we have seen that, like to handle this kind of operations, we need to go with operator precedence and everything. Okay, but like in case of when you look at the three addressing code, three addressing code is a form of representation which we need to understand. This is a form of representation. This is a form of representation of expression where there is at most one operator. There is at most one operator in right side of expression. So what is a representation where there is at most how many? One. So if you look at this expression, you will find that if we start numbering it, like how many operators are here, if we start numbering it, like you will find that, okay, the first operator is this one. Okay, second operator is this one, third operator is this one, fourth operator is this one, fifth operator is this, sixth operator is this. Okay, so almost there are many operators, like six operators are here into the right hand side of the expression, right hand side. So but like what we are trying to understand, what we are saying that whenever you have a code, then in this particular code you will have almost at most one operator into the right hand side of expression, right? And to the left hand side of the expression, and to the right left to the so this is actually, this particular thing is right hand side of expression, RHS. Okay, now then what is going to be there into the left hand side of expression? So the left hand side of the expression, to the left hand side and side, you may have either temporary or permanent variables. Okay, you may have either temporary or permanent variable. Now here permanent variables are nothing but the variable those are present into the expression. So they are permanent variable E. Then question comes to us is like, okay, what is temporary variable in this case? Now temporary variable are the variable that is created dynamically, right? When you convert expression compatible with three addressing code, and using a short form TAC. So it's a tree addressing code. So what it means that if you have such kind of expression and you want only one operator to come here, where to the left hand side either I can take a temporary variable or permanent variable. So here I can what I need to do is I need to convert this entire expression into a three addressing code. So like let us try to convert this into a three addressing code now. Like for example, now we are trying to convert this. Okay, so let us try to understand. So like if we are going to do this, then we need to go for a temporary variable. So E is a permanent variable, A, B are the permanent variable. So in order to have only one variable at the right hand side, what we need to do is that we need to use certain temporary variable. Those are created dynamically. So we used to say that those temporary variables as say T1. So I'm going to say like T1 is, let us take first is A plus B. So A plus B, T1 is A plus B. Then I am going to have T2. T2 is C multiplied by D. Okay. Then I'm going to have, okay, then I'm going to have, I can go with say A plus B plus C. Okay, so then I can go for say like let us take a T3. So since this is a T1, this A star A plus B is T1. Look at here. So this is going to be my this segment is, this is going to be a T1. This is going to be T2. So which means I can like once I have T1 and T2 together, I can have T3 as T1 multiplied by T2. So we can have this as a simplified form. So we can say like, okay, this is T1 multiplied by T2. Okay, so this much part is over now. Then I can go for say my T4 is going to be say further A plus B. Okay, now my T5 is going further like T4 plus C. Okay, now if you look at here, you'll find that this particular section, this particular up to the to from this to this, what we will see that this is going to be my T3, T3. This is going to be my T4. This is going to be my T5 now. Okay, so now what is left? I need to join this, and this I need to make as T6. Okay, so my next variable is going to be now it is T6. T6 is my T3 plus T5. Okay, and this result is being assigned to whom? This result is being assigned to E. So here I am going to write like E is equals to my T6. Okay, now let us try to examine this, what we have done so far here. Okay, let us try to examine. Okay, so in this case what we have understood is like, say for example, if this is an expression, we are trying to convert this into this particular representation. Okay, now let us, if we look at closely here, you'll find that all RHS has only one key pointers here, right? The expression which is written into RHS right hand side of expression is containing almost or at most only one operator. Okay, almost only one operator. Right, now this is interesting. Okay, this is one key pointer. Next key pointer is total total only three at max, right? At max three argument exist. How many? Only three argument exist. Okay, what it means? It means to say T1 is one argument, T2 is one argument, T3 is one argument. Okay, so to the right hand side, there is only one operator with two arguments. On to the left hand side, there is one argument which is nothing but either a temporary variable or going to be a permanent variable. So this is means what if you look at this. So how many argument? Three argument. There exists a three argument and one operator. Okay, so these are the key points. So what does exactly it means that whenever you are trying to convert and whenever you are trying to deal with the three addressing code, the key elements are that to the right hand side of expression you must have at most one operator, and to the left hand side there you may have either a temporary variable or a permanent variable. So whenever you have got an expression, you are trying to convert it into that particular way. So like any complex expression can further be divided into a three addressing code. Now what exactly this gives me, and this gives me one more important key point, is like whenever an expression, no matter how long expression you are going to write, whenever you create such three addressing code representation, three-addressed code representation, it becomes simple. It comes simple, but it looks simple, but length of code are getting increased. Okay, length of the codes are getting increased. So you can think of optimizing the length of the code further. So like for example, if like we already have a plus b and which is written as t1, so instead of putting t4, can I write t1 here directly? So means what it is like further optimization of code. So the opportunity for this is like once you have a three addressing code here, you can think for optimization also. Okay, but that is not optimization, but this is not a part of present discussion, but this is an opportunity where we can think of optimizing the code. So what we understand is that whenever any expression that we are going to have, when that expression is converted into an intermediate representation form, particularly to the three addressing code form, then the length of that particular expression which we have written into onto a one line but can be is being converted into a lengthy form, right? This is lengthy because we wanted to use only three arguments at max here. Okay, so these three addressing codes are being presented. These three addressing codes are being presented into uh, three representations. So it has three forms of representation. Three forms of representation, right? What are they? They are called as quadruples. Then second, they are called as triples, and next they are called as indirect triples. Okay, so they are quadruples, triples, and indirect triples. Okay, now what exactly quadruples means? Quad means four. Okay, so quad means four. So it means what? You have a tabular representation here. Quadruples means quad means four. So you have uh, a tabular representation where 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 the entire expression where the expression of three address code is presented in four column structure. Okay now what is that four column structure? Let us try to understand. Okay, so what you have is, first is like you have operator, then you have argument 1, then you have argument 2, then you have result. Okay, so how many columns are there here? You just try to identify how many columns are there. There are only 4 columns. Okay, so these 4 columns are being used for the representation of quadruples. Okay, for the representation of quadruples, these 4 columns are used. Okay, so now let us try to understand this with respect to a number actually. So we are going to give numbers to this particular expression. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Okay, so there are total 7 expression for one particular represent mathematical expression. So we are going to have this 7 rows: 2, 3, 4. Right now then, okay, so first operator in an expression 1 is going to be plus. So what is going to be argument 1? Argument 1 is A, argument 2 is B, result is in T1. Then first argument is C, second argument is D, and result is in T2. Third argument is again star, first argument is T1, second argument is T2, and the result is in T3. So in case of argument A, second argument B, result is in T4. Okay, now in case of T4, we are going to have T4, C, right, as an operator here, or operator, the argument is T6, and where the result is in E. So argument is equals to, then the result is C. Okay, we have not reused this here. We have not used equals to here like T1, T2, T3, T4, T5, T6. We have not used equals to, but we have used the operators that are there into an expression. Okay, so let us try to understand these terms. Like, okay, there are 6 entries into a table, so we'll just refer those 6 entries with a particular index. So this is 1, 2, 3, 4, 5th, and 6th. Okay, now what happens? Like, see here, how many arguments are here? Only 3 arguments, 2 arguments, 1 operator, and 1 expression. So the entire code which is written into a 3 addressing form is being converted into a quadruple structure. Now what happens? Result is not going to be B, right? So result is not going to be. So we understand that whatever the index that we have for a particular table, there you will find a result. Okay, there you will find a result. So we will find structure as this. So attributes here. So this is OP, this is argument 1, this is argument 2. So let us try to understand now. This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122 this is 5, and this is 6. Okay, so the operator here is plus, argument is a, argument is b. Okay, then operator is star, argument is c, argument is at what index, at what index is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6. So we are going to use that 0 index value and 1 index value. Because a plus b and c star d, so they are going to multiply here, right? So this is the value that we are going to multiply here, right? So then you have got plus, then you have got a, then you have got b. Now here then you have got uh, plus. Now the index value which is at 3 gets added with c. Okay, then plus, then the index value, that is t3 and t4. So that is means what, at the second, whatever index value is there, okay, so they are going to get summed here. So it means that, okay, so this is 2 and this is uh, 4, right? Okay, so this is, you can say this is 2 and this is 4, you summed here, and here you have got uh, uh, fifth index goes to e value. Okay, so what is interesting here, if you look at the important point which is which stands here, is this, that in case of triples we don't have this result part, so we optimize this result part and we convert this result part into result part into in this particular way. Okay, so means what, we have referred directly the indices. Okay, so these are the important points. So here we have referred the indices. Okay, so what is the benefit of this? The benefit of this representation is that, you have reduced one column, right? So you have reduced one column and you computed this. Okay, so means what, the in case of a symbolic structure or in case of a memory consumption structure, triple takes less structure as compared to quadruples. But in case of indirect triple, what happens? Indirect triple present up of the access. So for speeding up of access, what we are going to do is we are going to maintain the index. Okay, so we are going to maintain the index. So in case of indirect triples, what we are going to have, we are going to have an index only. So this is going to be my index, and this index has certain, this is my index table, right? And this index is pointing to a triple structure. In case of indirect triple, this is pointing to my triple structure. So means what, this is pointing to this. So this will hold a 0, right? So this will hold 1, this will hold 2, this will hold 3, this will hold 4, this will hold 5, this will hold 6, and this will hold 7. Okay, so means like if this is going to be like this, so this is 3 here, this is 4 here, this is 5th here, and these are 6th here. Okay, so this is how actually indirect triple structure works. Okay, so we don't have this here, like say we have got it's something like this. So so here we have an index structure. So this index structure is being accessed, right? And this index might be of, like say, at any different memory location. Say memory location, this will be say 100, 101, 102, 103, 104, 105, 106. Okay, so in case of indirect triples, what I am going to use is that additional index for a triple structure that is going to be there. So what is going to come into access is indirect triple index. Only we are going to refer back to an index, and here the entire three addressing code is being converted into a triple structure. It is being stored. So means what? The key pointers here, it maintains, in case of indirect triple, it maintains it maintains triple representation and triple representation and their and it is remembered, okay, and being accessed by index table, and uh, being accessed being accessed by index. Okay, so why it is being accessed? For speed up, right? So for fast speed, or for this clear idea about three addressing code.